Good day, everyone. Welcome to our discussion today. We are going to solve another example for solvable group of trigonometric integrals, group 4. So this is our example number 2. So in our example number 2, we're given the integral of sine x multiplied by cosine 2x dx. Okay, so to solve for this problem, we're going to do these steps. So these are the steps of our solutions. So first we need to rewrite the given. So the given is integral of sine x times cosine 2x dx. Then after that, we're going to use the identities. We use the trigonometric identities. So use the identity. So what identity is that? So we have, if you can still remember from what we have discussed in our first example. Okay, so we have here the identities. Alright, so these are the trigonometric identities. So since our given is in terms of sine and cosine, so we can make use of this. So this sine and cosine, so we can make use of this. Okay, so this one, sine x times cosine y equal to 1/2 sine, the quantity sine of the quantity x plus y plus sine of quantity x minus y, closed quantity. So we can make use of this formula. Okay, or in our previous example, we make use of sine t. Okay, so in our previous example, we also have used this formula. So cosine t, sine s, product of cosine t and sine s equal to sine of s plus t plus sine of s minus t, then divided by 2. Okay? Or this is just the same as this. Here we use x and y. Here we use t and s. Okay, using the I and t, s and t, so we can write our identity. Our identity can be this one. We have cosine t. You can put this, you may put this inside the parentheses or no need to put it inside the parentheses. So it's up to you, no? So you have cosine t times sine t so this is just equal to sine of s plus t, then plus sine of s minus t, then divided by 2. So we can make use of this identity class. Alright, so using that identity, so from our given, so what is our, not from our given, what is our s, or what is our t? So cosine t, so our, okay, so sine x, we have here sine x. It means that after sine, that should be our t. So we can say that in our given, our t is equal to x, right? Then our s is equal to x. Because t here, for this formula cosine t, that t is for the cosine. Sorry, I missed this one. This should be s. Sorry, class. This should be s. Okay, so that should be s. Cosine t times sine s. So we can say that our s here is after sine. Okay, so our sine here is x. So our s is equal to x. So meaning this s correspond to x because sine x, so s is equal to x. Then cosine t, so our t corresponds to x. Okay, so using the formula, so we can say that this is now integral of we have sine so sine x, our s is equal to x, so sine x, then plus our t, because s plus t, where our t is equal to 2x, then we have plus, so we put this inside the parentheses, then plus sine, that is still sine, but this time we have s, our s is once again is x, then minus our t is equal to 2x, so 2x, and divided by 2, then everything is multiplied by dx. Okay, so what's next? So after that we have to take out the constant. So taking out, or take the constant out, So taking the constant out, so what is left? So what is left now is, so it means, class, that we need to put this outside or on the left side of the integral. This is fraction of, this is understood to be 1/2. So we can rewrite this as 1/2 times the integral of sine x plus 2x then plus sine of x minus 2x. Then everything is multiplied by dx. Okay, so you have to put this inside a parenthesis or a bracket, so to mean that everything here is to be integrated with respect to x. Okay, then we have to simplify. So simplifying, so we have to simplify sine. Now we have to simplify sine x plus 2x plus sine x minus 2x. So when you simplify this, so what is left is, so this becomes so this one here becomes sine x plus 2x, so this will be sine 3x. So you will put this inside the parenthesis, then plus this is sine of negative x. Okay, where there's an identity that this one can also be written as sine 3x, then minus, no, you just put the negative here, sine x. Okay, so substituting, so after you simplify, so whatever is the result, you substitute it. So this becomes now 1/2 times the integral of, so this will be the integral of sine 3x minus sine x. So you put this inside the parenthesis. Okay, then multiplied by dx. Okay, then distributing the integral sign and integrate each term. So we have now 1/2. Of course, 1/2 is to be multiplied to each of the term. Integral of the integral of sine 3x, then multiplied by dx, then minus the integral of sine x dx. Where from our previous discussions, okay, I'll continue this in another cardboard. So from our previous discussions class, or from what we had discussed earlier, not today, but in the previous weeks. So we can say that, oh, by the way class, what we had done here, these steps, okay, so we apply here, so in this part here, okay, okay, so I will put the steps first. So what we did there is that we apply the sum rule, no? We have applied the sum rule. So applying sum rule, so applying the sum rule for integration. So what is the sum rule? We have integral of f of x plus or minus another function of x dx. So this is equivalent to integral of f of x dx plus or minus integral of another function of x dx. Okay, so that's why even if you don't write, or if you don't put the parenthesis class or the bracket, this red color, so if you have this form, you may just use this. If you have this form class, this is just equivalent. So equivalent to this. So that's why we have to continue this. So this is equal to 1/2 times the integral. Take note, 1/2 here is to be multiplied to each of the term. So this becomes the integral of sine 3x dx, then plus, sorry, this is minus, because it's minus here. So minus the integral of sine x dx. Okay, and we have from our discussion before, so we have integral of sine 3x dx. So this is just equivalent to minus 1/3 cosine 3x. All right, so where did we get this one? So how will we show the steps on how to get that one? So as mentioned earlier class, you have the formula, no? The integral of sine u. Okay, if you can still remember from these steps, if you have integral of sine u du, this is equal to minus cosine u plus c, right? So that is our formula. So now it's a matter of finding what is our u from the given sine u. So our u must be equal to 3x, right? So now we have to find we can substitute, no? The equation now above can be written as integral of sine, but we let this equal to u, so we have now sine u. So if we replace 3x by u, then we also have to replace dx. So we replace dx by du. So how will you solve du? So from here, the derivative of u with respect to x is equal to, so this is just 3 is equal to 3 dx. So this is 3 times dx. Okay? Now if you look at the given, our dx, if you look at the given or the resulting integrand here, or integral, so we have sine u du. So our du, oh by the way, from here we can solve du. Our du here is equal to, our du is equal to, just cross multiply dx class. So this is sorry, when you take the derivative of u with respect to x, so du over dx is equal to derivative 3x equal to 3. Solving for du, cross multiply dx, so we have 3 times dx. So this is our du. So since we substitute u equal to 3x here, this is our u, so we have to replace this by du. Okay, so that's why after substituting, so okay, so I'll continue this one here, class. I'll just show you why is it that the integral of sine 3x dx is equal to minus 1/3 cosine 3x. Okay, so let's continue. So this is 1/2 1/2 times the integral of sine 3x. So sine 3x, where our 3x is equal to u, then since our du here is just dx, okay, so since our du is just dx, we need 3, right? We need 3, so we have to insert 3 here. Okay, we need to insert 3, but as mentioned before, we are now altering the given function. So to retain it as at its original scenario, or its original given, so we need to balance it. We have to multiply it by 1/3. So multiply this by 1/3. Okay, and then you can now integrate it using the formula. Okay, this formula, this one. So this should be minus cosine. Okay, so I think this is very confusing to you, so I think I have to do the substitution method so that you will not be, or we can continue with this one, but you can use substitution method to make it easier. Okay, so now we can solve this using this formula. Integral of sine u du equal to minus cosine u plus c. Okay, so to continue, that is only for the first term. For the second term, minus. So the second term, there's no problem because the integral of sine u, or u here, for the first term, our u is just x. So sine u du. So we can immediately use this formula. Okay, so integral of this one, I just rewrite class. Integral of sine x dx. Okay, so simplifying, we have 1/2. The 1/2 here is, by the way, the 1/3 should not be put outside the bracket. It should be inside the bracket. So sorry, not the 1/2 but the 1/3. So the 1/3 should be here. Okay, it's not clear. Let me write it class so that you can read it. So 1/2, we have 1/2 here, then you have the bracket, then you have here the 1/3. Okay, so 1/2 times, so you can now apply the formula. So we have here 1/3 multiplied by integral of this is minus, right? This is minus cosine 3x, then minus integral of this, integral of sine is minus cosine, so minus cosine x. Okay, then plus the constant of integration. Any question? So next we have to simplify. So this becomes 1/2 times, we have 1/3. This is negative 1/3. Sorry, this is not. This is 1/2. 1/2, then multiplied by negative 1/3 cosine 3x, then minus minus, so that becomes plus cosine x. You can put x inside the parenthesis, or you may choose not to. Okay, so cosine x, something like that, then plus the constant of integration, plus c. Okay, so this can be our final answer, or you can distribute 1/2. So when you distribute 1/2, so this becomes minus 1/6 cosine 3x, then plus 1/2 cosine x, then plus c. So this is our final answer. Okay, any question? So this is it. So for your activities today, you may try to solve. You may try to solve the following. For another homework. So for your other homework class, you try to evaluate the following. So number one, integral of sine x squared plus 1 times sine x squared minus 1 dx. Okay? And the other one is integral of sine x times sine 2x dx. Okay, so you may opt to put this inside the parenthesis or not inside the parenthesis. That's okay. All right, so thank you very much, and I expect your output before midnight today. Okay, thank you very much. Bye.